Hello! Yes, and welcome to our Objective 1.2 note. So Objective 1.2 says I can state the domain and range of a given function. Domain and range are going to be our bread and butter today. So let's talk about what domain and range are. Domain is the set of all inputs or x values that create an output for the function. So our domain is the set of values that we can put into a function. The range is the set of all outputs created by the function. Now the outputs align with our y values. All right. So think about the domain tells what you can put into the function. The range tells what you can get out of the function. All right, now before we really get into domain and range of functions, we need to review interval notation because that's going to be how we write our domain and range. So in using interval notation, we use hard or soft brackets. Now hard brackets are the ones with the 90-degree angles. They look like this. And they're used when the value is contained within the solution set. That means it's either less than or equal to or greater than or equal to. If it's equal to, we're using that hard bracket. And graphically, that corresponds with a closed circle, a filled-in circle. That tells us it's less than or equal to, greater than or equal to. It is on that point, which means we are going to use a hard bracket. Soft brackets, on the other hand, look like parentheses. Now, don't confuse these with coordinates. They're very different. All right, soft brackets are used when the value is not contained within the solution set. And I have that written that way, so you specifically will write not contained within the solution set. Inequalities that are not contained within the solution set are those less than or greater than, the ones that are not equal to. And that corresponds with an open circle on a graph. We also always use a soft bracket when the interval goes to infinity. If you wonder why, that's a great conversation for us to have. I'd be happy to answer that question in one of our Zooms or when we meet in class. So what I'd like us to do is use what we know about interval notation to do some examples together. So write the following inequalities using interval notation. Letter A, x is less than 6. Now when we write interval notation, we always go from least to greatest. So by saying x is less than 6, we need to think, okay, then what is the least value x can be? Now some people might think 0, but that's not true because that doesn't include all the negatives. So what's the least negative number you can think of? Well, it's actually not a number. It's infinity, negative infinity. And since infinity always uses a soft bracket, that left bracket will be soft. And it goes all the way to 6. Now since this is also less than strictly, it'll be a soft bracket. And this would be letter A in interval notation. Negative infinity, comma 6, soft brackets all around. All right, let's look at letter B here. X is greater than or equal to 12. So, what's the smallest value x can be? Well, if x is greater than or equal to 12, 12 is the smallest value it can be. And since it's greater than or equal to, we'll have that hard bracket. Now, what's the largest value x can be? Well, it doesn't say how big it can be. It can be, as long as it's bigger than 12, that's okay. So what's the biggest value we can think of? Infinity. So hard bracket 12, comma, infinity, always with the soft bracket. C, negative 18 is less than or equal to x. Okay, so I'm a stickler here, and I like my variable to come first. So what I'm going to do is I'm going to rewrite this one. And I'm going to say that x is greater than or equal to negative 18. To me, that just makes more sense. It's easier to conceptualize in that way. Because this is saying that x has to be greater than or equal to negative 18. So that tells me negative 18 is the smallest value we can have. Since it's greater than or equal to, we can give it a hard bracket. And then there's no limitation for how big it can be, so that means infinity. All right, let's look at letter D here. Negative 3 is less than x is less than or equal to 7. So I think this is the one that is easiest to switch to interval notation. All we need to do is do a soft bracket for negative 3, since it's that less than symbol is not equal to, and then 7 is the largest value it can be. Since it can equal 7, it'll have a hard bracket. And there we go. All right, so this A through D, go ahead and pause the video. I want you to try E through F on your own. You can see E through F here. Let me give you a little more space. Go ahead and try E through F on your own. Go ahead and pause. Try those. Okay, let's check these together. So first, x is greater than 149. That tells me 149 soft bracket, because it's strictly greater than, is the smallest value it can be. Infinity would be the largest. Okay, negative 68 is greater than or equal to x. That's the same thing as saying x is less than or equal to negative 68. So with that in mind, I can see that x has to be smaller than, less than, negative 68. So I'm going to say negative infinity is the smallest it can be. The greatest it can be is negative 68. And since it has that hard bracket, that means, or since it has that greater than symbol, since it has that equal to symbol, excuse me, that hard bracket's going to be there. Speaking hard. Okay. So 11 is less than or equal to x is less than or equal to 25. Straightforward here. Hard brackets all around. 11 is the lowest it can be. 25 is the highest it can be. All right. 0 is less than or equal to x is less than 15. So I'd have hard bracket 0, comma 15, soft bracket. Hopefully we're feeling more confident with the interval notation. If that's something you still need to work on, feel free to let me know and we can get you some extra work there. But now that we're good with that, let's talk about domain and range. So remember that domain is the set of all the x values or inputs. Range is the set of all the y values or outputs. So when we're looking at something graphically, all we need to do is say, if I'm asking domain, how far to the left and right does it go? If I'm asking range, how low and high does it go? So looking at letter A here, my domain is going to be, well, it goes all the way to the left and negative 6. So negative 6 is the least it can be. Notice the open circle, that corresponds to a soft bracket. The furthest to the right it goes is 7. Notice the closed circle, that corresponds to a hard bracket. So my domain is soft bracket negative 6, comma 7, hard bracket. My range is low to high. So how low does it go? It goes to negative 3. Notice open circle tells me soft bracket. How high does it go? It goes to 4 with a closed circle, hard bracket. There we go. Soft bracket, negative 3, comma 4, hard bracket with our range there. Looking at letter B, my domain is left to right. How far left does this go? I have a, let's see, open circle at negative 2. Open circle will have that soft bracket. And how far to the right does it go? It goes all the way to 4 with a closed circle, hard bracket. There we go. Now, the range is how low does it go? How low can you go? This one can go to negative 7. Got that soft bracket. How high? 9 with a hard bracket because of that closed circle. And that's how we can see the domain and range from a graph. Let's talk about domain and range from equations though. So in this unit, we're really going to focus on 5 different types of functions: linear, quadratic, cubic, square root, and absolute value. So if I want to start by looking at linear functions, let's think about a line. Think about the line maybe y equals mx plus b. I don't know why that is moving. We'll let it happen. All right, so think about a line that if I were to graph it, that line on a coordinate plane would go forever in any direction at once. And I don't know why it's moving my pretty artwork here, so I won't try that again. All right, so y equals mx plus b is moving forever and ever in both directions, left and right. Correct? So that means there's going to be no domain restriction. So my domain for any linear function is always going to be negative infinity to infinity. There's no restriction. Now, my range restriction is the same idea here. Since I'm always moving left and right, think about if there's any slope on that, any slope other than 0, I'll also always be moving up and down. So that means there's no restriction on my range either. And I don't know why it's moving my artwork. That's a little frustrating. That's okay. Technology is our friend. Okay. So there's really no domain or range restriction. The only exception I can think of is horizontal and vertical lines, and we'll discuss those more in person or through our Zooms. Now, a quadratic equation. Think of a quadratic equation like y equals x squared. All right, so a quadratic equation makes that shape of a parabola. So that parabola is going to look a bit like that. Oh, it's moving on me again. Think about what that means as far as our range goes, okay? Let's take a pause and look at a graph here of a parabola. So I have graphed here y equals x squared, and notice the shape that we have here. So the domain is going to be going to the left and right. That shape's going to continue going to the left and right forever and ever. That's not going to change. But what do you notice about the range? The range doesn't go below 0, 0 here. Okay? Now notice this parabola has a positive coefficient, a positive leading coefficient. What happens if I make it negative? If it's negative, the graph goes down. So now it has a maximum value of its range. So that matters for our domain and range. So let's go back to our table here. So our domain restriction, we said it'll go to the left and right forever. There isn't a domain restriction. It's always going to be negative infinity to infinity. However, our range restriction, it depends on the leading coefficient. Depends on LC. I don't... hopefully you guys are seeing this like I am. I swear I have better handwriting than that, but we're having some fun today. Depends on the leading coefficient. Now, what else it depends on is also the max or min value, because that'll tell you how high or how low it goes. So that's another thing to keep in mind for our range restriction. So for a quadratic, domain is always negative infinity to infinity, but the range depends on the leading coefficient and the max and min value. Now a cubic function, think y equals x to the third. Y equals x to the third does not have a domain restriction or a range restriction. It is like a linear. It is negative infinity to infinity for both every time. If it's a cubic function, negative infinity to infinity for both the domain and range. Now a square root function, that is not the case. Think about y equals the square root of x. There are values that we can't put in for x. We can't put in a negative number, okay? We can't get out a positive number. Let's look at what this looks like graphically. So we have graphed y equals the square root of x. Notice how my domain is going to be everything to the right of 0. So this would be 0 to positive infinity for my domain, closed circle, hard bracket here at 0. Notice my range, okay? My lowest point is 0, and I go up from there, right? I move up from there. So my range would be 0 to positive infinity. Notice we don't have any negative x, and we don't have any negative y. Now that can change, again, if we flip the graph. If we flip it over the x-axis, notice now we're still going to the right. We're always going to be going to the right here. However, now 0 is my maximum value, and I will have a negative y. I'll have negative range outputs. So my domain would still be 0 to positive infinity, but my range is going to be 0 to negative infinity. Okay, now we can also move this up and down, so it's also important to think about the transformations that occur when we're looking at the domain and range of a square root function. So back to our table, the domain restriction is we are going to have greater than or equal to transformation value. Now our range is going to be a little different because it depends on the leading coefficient. If there's a negative, let's see if I can get this to work. I don't know why it's moving my text. And on the transformation value. All right, so I'm just going to draw an arrow there to show that that depends. The transformation value affects both the domain and range. And if you're not sure about that, that's definitely one we'll learn more about this unit. And we'll talk about in the sample problems video as well. So the last one, the absolute value. The absolute value is a lot like the quadratic. Think y equals the absolute value of x. Instead of making that U shape the quadratic makes, it makes that V shape. And those didn't move. Weird. So same idea here. We're going to be able to go to the left and to the right forever. So my domain is going to be negative infinity to infinity. Piece of cake. My range, however, depends on the leading coefficient. If I put a negative in front, it would flip this v over. And it also depends on the maximum or minimum value if I shift this up or down. So let's see if I can fit this in here. Depends on the leading coefficient and the max-min value. There you go. Okay. And those are the domain and range restrictions for the functions we're going to deal with more. If you're feeling confident, that's awesome. Go ahead and check out those practice problems. If you want a little more practice, let's look at that sample problems video together, all right? Mr. Carter signing off. I'll see you next time.